Alright guys, this is going to be chapter 6, number 6.9 for Statics Exam 2 review. So this is going to be a truss system. We have a pin at C and a roller at F. Given to us also is a 8 kilonewton force going down at A. They are asking us to find all of the forces in each member. So we need to find a way to do this. So we need to know if we need to use method of joints or method of sections. Now, on the method of sections, you are restricted to only being able to make a cut through only 3 members. So, if we tried to make a cut in this truss, if we do one right there, we go through 1, 2, 3, 4 members. So we cannot do that. Okay, so let's try another direction. So say let's make a cut right here at this angle. Well, same thing. 1, 2, 3, 4. So now we're seeing a pattern. It looks like method of sections is not going to be working for this system, so we are going to have to do it by method of joints. So we start off by making our free body diagram. Our free body diagram, we have a pin at C, so we have a CY, CX. We have a roller at F. I have it stated as a positive in the X direction going to the right. And we have the 8 kilonewtons down. I went ahead and drew this angle theta from the horizontal. We'll be using that later to find our interior angle. So to start it all off, we need to take our entire system, sum of forces. So we're going to take sum of forces in the x equal to 0, positive in the positive right direction. We have Cx plus f of x is equal to 0. Our sum of forces in the y is equal to 0, positive in the vertical up direction. We have a negative 8 kilonewtons plus Cy is equal to 0. We can solve for Cy right now. Cy is 8 kilonewtons. But we still don't know Cx and the Fx, so we need to take a sum of our moments. We're going to take a moment about C, saying that counterclockwise is positive. We're going to have our force in the x direction times its perpendicular distance, which is going to be 3.2 meters, plus our 8 kilonewton force times 6 meters, all equal to 0. Now we can solve for f of x. F of x is going to be a negative 15 kilonewtons. So it's going to be to the left instead. Now that we know f of x, we can solve for c of x. Solving for cx, we get a positive 15 kilonewtons. Okay, so now that we know our reactions, we can start using method of joints. So when you start these off, you need to start at the joint that you know the most amount of forces. So right now, our point C, we know more than anything else. We know this one and this one. All we need to find is force BC and force CE. So we're going to start off at joint C. Always label which joint you're going to from first. That way Jackson knows when he's grading it to know where you're at. So label it C. We have our force in the CUI. We have our force CX. Now remember, always draw your arrows going away from the joint. Unless you know the force. So like on this one, we know that it's 8 kilonewtons positive, and Cx, which is 15 kilonewtons positive. If you have an unknown force, which is our members, draw those away. So we have force CE, and we have force BC. Now we have our free body diagram set up for our joint. We need to take our sum of forces in the x and the y. Sum of force x equal to 0, positive in the x direction. We get a negative force BC plus 15 kilonewtons is equal to 0. Solving for that one, we get BC is equal to 15 kilonewtons. Now it's positive, that means it's in tension. That is our first member. Now we'll take our sum of forces in the y is equal to 0, positive in the x direction, or positive in the vertical y. We get a negative F CE plus 8 kilonewtons equal to 0. Force CE is equal to positive 8 kilonewtons, which is also in tension. Okay, so first two members are already knocked out. So now we need to go to the next joint that we know the most amount of forces. So for this one, we have our reaction at F, so we're going to do joint F next. Again, state which joint you're doing your analysis from. We have point F right here. We know our direction of our f of x, which is a negative 15 kilonewtons, going to the left. We don't know our force Fe, so force Fe. And we don't know this force at this angle, which is force dF, which is going to be at that some angle theta. Now to find theta, all we need to do is look at our triangle. Our triangle, we have 1.6 and 3, so we can find our angle right here, which is beta. So beta is going to be inverse tangent of 3 over 1.6. That will come out to 61.93 degrees. Now we need to find our theta. Our theta is going to be 90 plus 61.93 minus 180. We will get a theta to be 28 point, I believe it's 1 degrees. Now we can do our sum of forces. Sum of forces x equal to 0, positive in the right x direction. We have a negative 15 kilonewtons minus our force dF times our cosine of theta equal to 0. We can go ahead and solve for a force Fd, or dF. Force dF is equal to a negative 17 kilonewtons. It's negative, so it is in compression. Now take our sum of forces in the y direction is equal to 0. Positive in the vertical up direction. We get force Fe plus force dF sine of theta is equal to 0. Knowing theta and everything else, so we know force dF, we can find force Fe. Force Fe comes out to 8 kilonewtons positive, so it's in tension. Okay, we're moving right along. So now we know a total of what, four beam members so far. Now we can move on to our next joint. So we now know this member, this member, this member, and this member. So we need to take our next point that we know the most. We have the most knowns. So that is going to be joint E. Joint E. So we'll make our dot saying that this is going to be at E. Drawing our forces away, we get our force Fe force CE. We have this force at angle BE. And this force member DE. Now we need to know what this angle is right here. I'm going to label it as lambda. Now, to find lambda, all we have to do is look back at our triangle. It's going to be inverse tangent of 1.6 over 3, we're going to have lambda come out to also 28.1 degrees. You can also look at this just as your law of triangles and your law of interior angles. It's also going to be the same from what we found for theta. It's just moved up. Knowing that, we can start doing our sum of forces in the x and y. Sum of forces in the x, positive in the x direction and to the right. We have a negative force dE minus our force BE cosine lambda equal to 0. Now we have the sum of forces in the y direction, positive in the up direction. We have force CE minus force FE plus force BE sine of lambda is equal to 0. We go ahead and plug in on our f of y equation because we know our force CE and force FE. That will be 8 kilonewtons minus 8 kilonewtons plus force BE sine lambda is equal to 0. That will come out as force BE is equal to 0. Now we know force BE, we can solve for FDE. Force DE will also be 0. Okay, now going back up to our free body diagram, we now know that joint and this joint. So all we have remaining is AB, BD, and AD. Now if you look at this triangle, we have an 8 kilonewtons going down, which is going to cause this member going to be in compression, this member be in tension. However, this guy is going to be pushed and pulled from each direction. Because of so, this will force BD, member BD, is also going to be a 0 force member. If you are any kind of confused by that, feel free to go ahead and do method of joints on one of those. You can do a method of joints about B. You'll have two unknowns and two knowns, and you'll find that force BD will come out to 0. Okay, so that leaves us down to one more joint, joint A. So looking at joint A, we have a negative 8 kilonewtons going down. We have our force AD down to the right, and our force AB directly right. Now, this angle is also going to be lambda, which is also theta. Solving our forces in the x and the y. We have force AB plus force AD cosine of lambda is equal to 0. We can go ahead and solve for force AD is equal to negative 17 kilonewtons. And that is in compression. The reason why is because force AB is also equivalent to BC. This force member right here is also going to be the same force member right here. That's what it's going to be experiencing. We said that BC is 15 kilonewtons. That is why I have that number right here. Force AB is equal to force BC, which is 15 kilonewtons in tension. And that is it for this chapter 6 problem. Now, I know I kind of went through that fast, and I kind of did some assumptions that you probably won't see right off the get-go. So, feel free to do continuing on and do joint B and then joint A to finish out the problem so you can see how you get 0 and how you get your force AB is also equal to force member BC. Okay. Alright, that is it for this chapter 6 problem. We have one more chapter 6 problem to do, so stay tuned for the next video.